balancing redox or reduction oxidation reactions. Remember, these reactions involve transferring electrons from one reactant to another one. So why not harness that transfer of electrons? You make it do some useful work, right? Operate your toothbrush or something, right? So that's exactly what a battery does. And once those reactants or one of them runs out and is depleted, well, the battery's dead, right? So there's a lot of uses, and these reactions are numerous. And what we're going to do is work on balancing them, how to balance these reactions so we can predict their products and all that sort of thing. Now, there's a lot of steps, and I don't know, I'm kind of different. I love it. I like it because I don't like memorizing things. I don't like the unlogical nature of how we balanced reactions before. There was no method to it. I just hated it, actually. I didn't tell you that when we were doing it because that doesn't help me teach it. But I hated it because there's no, I can give you some hints, but there's, so we're going to follow these steps. And you've got the steps, but hopefully, you know, it'll just come to you because it's logical. Now, what I did, this is not the first one that's listed in your notes. This is the very last one. And I moved it up to the very front one because it's the most difficult one. It has all the tricks. It has, if you can handle this one, you can handle anything. So I want to handle this one together, and then we'll go to the boards and start with some easier ones. But let's go ahead and start working this one out. So we are going to balance this redox reaction. It's supposed to be unbalanced. And you can kind of tell it's unbalanced. I mean, you've got 4 oxygens here, and only how many oxygens on the product side? 3. So it's unbalanced. And how the heck would you balance that? The charge isn't even balanced. And then it's redox reaction. You have to dig into it harder to see it because what the oxidation states are actually changing. So there is a transfer of electrons going on here between cyanide and permanganate. So let's go ahead and get started. The first thing we're supposed to do is break this unbalanced redox reaction into half reactions. Okay? And when you're doing this, you want to write as neat as you can because we have to see how things cancel and add things up. So you want to write as neat as you can. So we're going to write 2 half reactions. That's what the 2 upper arrows are for. We're going to add everything up and get our final answer. And that's what the bottom arrow is for. So write each reactant here, pretty much cyanide. And it goes to, you pick the product that it turns into. It gets converted into CnO -1. Okay? And the permanganate, it gets converted into MnO2. Okay, so they call these the half reactions. They're not balanced. One of these reactions is going to produce electrons. The other one is going to react with them. So that's a sign that we screwed up if we don't have electrons on opposite sides. And you'll see where the electrons are coming from. But okay, so starting with the steps, let's balance the top half reaction first. All right? And it says balance everything but oxygen and hydrogen. So we balance the carbons and the nitrogens. Well, they're balanced, right, on that side. So move on to the next step. The next step is balance the oxygen by adding H2O. Okay, so the oxygens are not balanced. We need to add water, Daisy, to what side? The reactants or the products? The reactants. And how many waters? 2. Let's see what it looks like. Yeah, right, 2. Right? Did we add too many waters? Right, we did, right? Because now we have 2 oxygens. All we needed is 1, right? Right? So it's helpful, Daisy, to do that. Okay, so now we have the same number of oxygens on both sides. We just screwed up the hydrogens, though. But you have to do it this way. It's the quickest way to get to the right answer. Now balance the hydrogens by adding H plus to the appropriate side. So Alejandro, how many H pluses do we have to add and where? 2 H pluses to the product side. I agree. Now our hydrogens are balanced. We have 2 H's on both sides. Okay. Now I think this is the most complicated part right here. You have to balance the charge by adding electrons, E negatives, to the most positive side. And to figure out what side is the most positive is where people have a lot of difficulty. So we want to go through this step kind of slow here. All right, that's maybe, right? Okay, let's do this side first. Its entire charge. And how you get the charge on the side is you multiply the coefficient times the superscript, right? And add that up for the entire side. So for example, for the water, it would be 1, right? Where's the 1? Because the 1 is right here, right? But no one ever writes it. Times, what's the charge on water? Right? Look up, I can't jump that high. But what the superscript on the water is, there's nothing written there. So it's a 0. And that is the weird thing about charge, isn't it? Because when nothing is written there, doesn't that usually mean a 1? That's the screwy thing about charge. But realize if it's a 1, it would look like the H+. So nothing is written there means 0. So you'd have 1 times 0 plus what times what for cyanide? 1 times a negative 1. So on that side, this entire side, I have what for an overall charge? Negative 1, right? Because I have a 0 plus a negative 1. I've got negative 1. Make sense? You got it? Okay. Do the same for the other side. So I'll have what for dulce? I'll have what times what for CNO negative here? Excellent. 1 times a negative 1. Plus, I have to do it for every single thing that's up there. So Jonathan, what times what for the 2H pluses? 2 times a 1. All right, so my overall charge then, Erica, would be what? Right, I'll have a negative 1 and a positive 2, so I ended up with 1. Yeah. So I have a positive 1. Okay. If you end up with the same charge on both sides, you screwed up. Because redox reactions, that charge has to change because it lost electrons or it produced them, one or the other. So you can't end up with the same charge on both sides. You screwed up. Okay, Annabelle. We're on the step where it says balance the charge by adding E negatives to the most positive side. Which side is the most positive? The products or the reactants? The products. Okay, so right away I write plus E negative. Okay, how many of those negatives do I have to add to that most positive side? So I'll have the same charge on both sides. Anybody? Right? Let's try 1. A negative 1 and a positive 1 gives me 0. So not enough. So whoever said 2, they got it, right? Because you had a negative 2 and a positive 1. Now I've got a negative 1 on both sides. It works. Right? Good. So it's helpful that you said that, Oscar. Okay. Clean that up. We're done with that top one. We're done with it. Have to do all those same steps for the bottom half reaction. Okay, so Katrina, we're supposed to balance everything. I'm doing the very first step now. Balance everything but oxygen and hydrogen for this half react, the bottom one. Yeah, they're already balanced, so quit. And then we balance, Clarissa, we balance the oxygens by adding H2O. Balance the oxygens by adding H2O. Let's try it. If you throw one over there, now we have 1 plus 4, 5 oxygens. Yeah, too many. So it has to be to the product side. And so you just try it. If you're not sure, you just do this. You try it, right? So we put it over here, right, Clarissa? How many do we need? 2 of them. right? And remember, by adding waters, it's these coefficients that you're messing with. You can't change these subscripts. You change the subscript, it's not water anymore. So 2 H2Os. Oxygens are done. 4 oxygens on both sides. So Shelby, now we're supposed to balance the hydrogens by adding H plus to the appropriate side. 4 H pluses on the reactant side. Okay, because we have 4 hydrogens on the product. Okay, now we have 4 hydrogens. And notice how important it is. Dang, that's a huge difference. See how important these charges are? They're really important because the next step is figuring out the charge on both sides. Okay, now let's do the charge here. Let's make some space to do this. Okay, the charge on this side. The overall charge. Tegan, how am I going to get the overall charge on this side? 4 times 1 and 1 times a negative 1. Okay, I don't like doing math, but I have Christian here. What's the total on that side then? 3. And I'm going to circle it because I want it obvious. Positive 3 even. Okay, do the same on the other side, Oscar. What's my overall charge? It'd be 1 times, right, because there's a 1 here. 1 times 0 and 2 times, well, no. You just multiply the coefficient times the superscript. So you got it. 2 times 0. So that side, everybody, is 0. Okay. I strongly suggest writing these numbers because one little screw up and the whole problem they've been working on for 5-10 minutes is messed up. So plus 3 and a 0. You add electrons to the most positive side, Danielle, so that you get the same number on both sides. So what would you do? Add electrons to the most positive side. Definitely add them to this side. And how many? How many? Well, you try it. 2. A negative 2, right? Well, negative 2 and a positive 4 is positive 2, and a negative 1 is 1. This side's still 0. Or just look at those numbers that we circled. You have 3. You want to get to 0. Just add 3, right? Just add 3. It's easier to look at the circled numbers. Add 3 electrons. Because a negative 3 and a positive 3 will give me 0. Okay. So that side is done. Okay. Now where we're at is we have 2 balanced half reactions. So you got to add them up. Okay. Now you got to add them up. But you can't, if I added them up right now, notice I'd have 2 electrons over here, because everything on the product side, I just bring it down. Everything on the reactant side, I just bring it down. But then you kind of simplify, all that crosses out, end up with 1 electron. All right? You can't have electrons floating around. All those electrons had to get transferred from one reactant to the other one. So this, you can't do this. So you got to get those electrons to cancel before you even add them up. So you have to multiply each of these equations by something to get these electrons to cancel. Then you add them up. Okay? So we're at the step where we're adding the half reactions so that those electrons will cancel. What do you have to multiply these by?
3 and 2.
3 and a 2. Very good, Oscar. Top one times a 3, bottom one by a 2. So really we'll have how many electrons canceling? All of them, all 6. So just get rid of them so you don't have to worry about them now. You see that, Jonathan? Jonathan, you see what we did? Make sense? Okay. Now we just, hard part's really done. So now we multiply 3 by all those reactants, add them up. So like we'll have 3 H2Os and 3 CN negatives. Right? And then you add up the second half reactants. But you got to multiply them by 2 first. So 2 times 4, 8 hydrogen ions and 2 permanganates. And 2 permanganates. Okay? See where I'm getting this stuff from? Do the same thing for the product side. So now I have 3 CNO negatives. And what is that? 6 H pluses. The bottom half reaction, 2 MnO2s. And 2 times 2 would be 4 H2Os. Okay. Then in those steps that you have, they want you to simplify it. So really, it's kind of logical. You may not even need to follow the handout, but you can see that what's common on both sides that you can cancel out. Like these H pluses, I see them on both sides, don't you? So let's cross out all 6 of those. Yeah, because H pluses. And change that 8 to a what? A 2. Did I miss something? What else is common? The H2Os. Okay. Let's pick on Alejandro. Alejandro, cross out all these H2Os, right? And change that 4 to a 1. Okay. So, I mean, I don't think you can simplify it anymore. And we're at the bottom of the sheet where if in basic solution, we're at step 6, if in basic solution, they want you to do something. So if we were in acidic solution, like this one is, we could have quit at that point. But in this problem, we're in basic solution, so we cannot quit. We have to do this last step. In other words, if you're in basic solution, you can't have any H pluses floating around. It's basic. You don't have H pluses floating around. You have what floating around? Hydroxide. Basic solution. So you have to have hydroxides floating around. It's impossible to have H pluses floating around. So the step says convert all the H pluses to water. Okay. So if you have one H plus, how many hydroxides would you add to make water? One of them. And then we'd make 1 water. Well, we have 2 H pluses. So we have to add how many waters? 2 of them. So plus 2 OH negative. I'm going to circle it. And then I'm going to cross it out because it doesn't exist, and just write 2 H2Os next to it. Right? So I just converted all my H pluses to water by adding 2 OH minuses. But if I added 2 OH minuses to the reactant side, hadn't I better add it over there too? Right? Okay, so you have to add, if I have 8 H pluses, I have to add 8 OH minuses to both sides. Okay. Oh, did I screw up my waters now? I did, right? Because I had 1 here. I'm running out of colors. Orange? So this whole thing is gone, and that 2 becomes a 1, right? Because I have to cancel 1. Subtract 1 water from both sides. I had 1 H2O. Here I have 2. So if I subtract H2O from both sides, I'll end up with just 1 H2O. So, man, this is such a mess. I should really rewrite the thing. All right, let's rewrite the thing, make it look a lot neater here. So my final answer would be 3 CN negatives and 1 water. Let's see, what else do I have here? 2 of those permanganates would give me 3 CNO negative, 2 MnO2s, and 2 hydroxides. Okay. Now, like I said, this has all the tricks in it. This is the hardest problem you're going to see. Let's do one more thing before we leave. Let's say you got really good at this. Right, Erica? You got so good at this, and there's like 15 minutes left on the exam. So you could turn it in and, you know, go do your thing. But she says, no, I'm going to check to make sure that this is balanced. I would say just look at the oxygens. Pick one, the oxygens or the hydrogens. If one of those is balanced, you're good. Don't even worry about it. So let's see if the oxygens are balanced. On the reactant side, how many oxygens do you see? Good. You see 5. Water and 8. So 1 and 8. Sorry, not. 2 times 4 is 8, and 1 is 9. Right? So I have 9 oxygens. How many oxygens on this side? 3 plus 4 is 7 plus 2 is 9. Right? So 9 oxygens. They're good. Okay. Let's see if it's truly balanced. You don't have to go this far, but it's good practice for you. Those charges. You have to have the same charge on both sides. I don't care whether it's positive 8 on both sides, negative 6 on both sides, 0 on both sides. It's got to be the same on both sides. So let's see if we have the same charge on both sides. That's good practice, because that's the hardest thing that you guys have to work with anyway. What is the total charge on that side? See if you can figure it out. Right? I hear -4, I hear -5. Right? You get the same number on both sides? Yeah. You get -5, right? Yeah. So it works. Bless you. So the first step in this whole mess, break it up into its half reactions. For each half reaction, do the following. Balance everything but O and H. Balance O's by adding H2O. Balance H by adding H+. Balance the charge by adding E negatives to the most positive side. Do that for both half reactions, add it up, and you're pretty much done. Just hope it doesn't say basic, right? Okay, so let's try this one. Let's go to the boards and let's try this one. This probably isn't B in your notes. It might be a different letter, but it's nitrate plus copper gives NO plus Cu plus 2. And it's an acidic solution. So we're doing the nitrate plus copper. Oh, Daniel, I got to erase all. That's all. You can't have all your answers in front of you. Now try to write neat, too. Try to write neat. Oh, you found an eraser. Okay. So try to write neat, because your life will be so much easier if you can write neat on this. NO3 negative plus copper. Now remember, break it into its half reactions first. Break it into the half reactions first. Okay? Goes to NO plus Cu plus 2. Yeah. So these are your product. Yeah, it goes to NO plus Cu plus 2. plus Cu plus 2. Yeah, no, copper goes to copper. Nitrate goes, right? Cu goes to Cu plus 2. And nitrate goes to NO. No, she's doing okay. Okay. You're okay. So break it into its half reactions. Break it into its half reactions. Okay. Oh, and remember, he has to be a plus. He has to be a plus. Okay. Oh, 2 times 2 is 4.
Yeah.
You need 4 of them. Okay. So balance everything but O and H. Balance O's by adding H2O. Balance H by adding H plus. There's no O's or H's. So Cu and Cu, yeah, just have to balance the charge. Okay. Well, hang on. No, you balance everything but O and H. N's are done.
Oh.
So you're done, right? Now you balance O's by adding H2O. You have to add them to this side. How many? Yeah, 2, because you need 3 oxygens. Because now you have 2 O's and 1 O, 3 O's. Now H's by adding H plus.
So
4 H's. Yeah. And it has to be H plus. Now charge by adding E negatives to the most positive side. Oh, I think here we're messed up. Because here you have 2 times 2 is 4 hydrogens. You need 4 hydrogens. 4 hydrogens. Okay. Positive 4, negative 1 is 3. Good. Yeah. Whoa, there's nothing written up there. There you go. Yep. Yep. You got it. Now do the same for the copper one. So maybe just kind of erase this and put the copper one right below it. And line up the arrows. Okay, now you got to, this looks good. Now you just got to add them up so that those electrons cancel.
Okay.
So you're going to have to multiply this top and the bottom one by something. Yeah.
These can't cancel out, right? Because that's a C
No,
plus 2.
yeah, that's because we're getting lazy. This should say solid, and that should say aqueous on it. But yeah, there's no charge on it, so you can't. And maybe see if your hydrogens or oxygens are balanced, and then that'll tell you whether you're right or not. Okay. So you multiply this one through by 3. Oh, you don't have any electrons on the top one. Yeah, you don't have any electrons up here. This whole side is 0, right?
Basic.
This whole side is a positive 3 because a 4 and a negative 1. So this side is positive 3. This side is 0. Most positive side, add E negatives. You add how many? You want to bring it down to 0. That's okay. You have a positive 3. So if you add, this just has a negative 1. So if you have to add 3 of them, you'd have a negative 3. Negative 3 and 0, sorry, negative 3 and a positive 3 would give you 0. And that's what this is. So that's what you want. 3 E negatives. And then you have to have a plus in there. Right? Because you're adding it to all this stuff. Okay, now you're good. So this one by 3 and this one by 2. So So that you end up having 6 electrons canceling. And try to be neat so you actually can see. Yeah, there you go. So you can see it better.
Is that correct? Because it's
I would
acidic?
see if the H's are, yeah. If
If it's acidic, you just need to-
acidic, yeah, you're done. But make sure the H's or the O's are balanced. If they are, then you're good. And if you got the answer, and your O's or H's are balanced, just go on to the next one. I'll scribble down the answer in case you're not so sure about it. You get it?
I don't know.
Oh, it said acidic though, so you quit.
Oh, that's why I was so hard to do that.
But if it said basic, you could. You're right. That'd be good practice for a basic. Okay, so you're getting it to work. So you're multiplying this top one by 2. You're putting it there. Bottom one times 3. Now you're multiplying it by 3. So that 3 goes in front. Okay, now this side, it'd be 2 times this, 2 times that. Write it down. 3 times 1. And write it there. I would cross out these electrons too, so that although you don't want to be writing them in down here somewhere because they're canceled. And 4 H2Os. And now the bottom. He's done. Now I'll do this one. And times 3. Yep, it has to be 3 of them. Cu plus 2. See, that's why I said cross out those electrons. You did here, but you didn't cross it out here. Yeah, so you're done. All right? Good. Try the next one. It says acidic. So the only thing that you can do is see if your oxygens are balanced. 2 times 3 is 6. Here you have 2 plus 4 is 6. So I'd say you quit. All right, looks good. What are you guys doing now? So which one are you guys doing? Yeah. Yeah. But you can check though. You can check to see if you did it. Like usually the only thing I check are the H's, the O's. Let's just do the O's. 2 times 3 is 6 O's, right? So that's all the O's, 6 of them. Here, this whole side, 2 O's plus 4 O's would be 6 O's. Good. Only when it's acidic can you have H pluses floating around. And you do have H pluses floating around, so you're good, so you quit. So if you're erasing, make sure you try this one, the one that's manganese and it's in basic. If you haven't done it already, make sure you do it. Try to do one of these basics before you leave. So if you have two H pluses, you have to add two OH minuses. And then you have to add two OH minuses to this side too. This is what I'd like to do. Instead of rewriting, I only want to rewrite this thing once. So what I'm going to do is I like to circle all this and cross it out or something and write two H2Os on it or something. And then fix your H2Os and then rewrite it all nice and neat. Yeah. How many E negatives? Two of them. Yeah, because this side, the other side's 0. So you have to get it down to 0. So this would be 2 E negatives. You're right. Good. Now you're done with that one. So now I'll do the next half reaction. The nitrate going to N2. Make sure you write your charges in. Okay, so you balance everything but O and N. Oh, but see, the N's aren't canceled. I'm sorry, the N's aren't balanced. You have 2 here, so you have to put a 2 over there. And remember, he's negative. Okay, now the N's are balanced. Now O's by adding H2O.
How do we cancel this negative?
You have one E negative, the other one is a 2, right? So just multiply this one by 2, this one by 1.
Okay.
Oh, yeah, they're gone. Boom, boom. And then your H pluses. Yeah, there you go. Make that a 2. So you cross him out there or something. Yeah. Okay. Well, I wouldn't rewrite it all yet. Okay. Right? Because now you're in basic. So you have to add 2 H pluses to both sides. Okay. Right? And then kind of circle this one and cross it out and write 2 H2Os. Then fix your waters. Then rewrite the whole thing all nice and neat. Well, okay, where are you at?
I don't know, I'm so confused.
Okay, so you have 2 H pluses here and 2 here. So you can cross all those out and change that 4 to a 2. Right? Just cross out the 4 or something and make it a 2. Okay, H pluses. Okay, you're in basic solution, right? So you have to add 2 OH minuses to make this 2 waters. We have to add 2 OH minuses to that side also. Right? Because you can't have H plus if you're in basic solution. So just write plus 2 OH minus and circle it because it's all one big thing.
Wait, so I'm going to do that.
Right? And then cross the whole thing out and write 2 H2Os next to it or something. So that's what you converted it into. So now you have 2 H2O's here and 6 here. You can write 8 or something, right? But don't forget to add those 2 OH minuses over there. Because you had all this nice and balanced
Wait, so am I
reaction.
gonna have 2 waters on each side?
They would end up canceling them if you did. If you did. Well, we'll check it out. Let me write it out.
What did I do wrong? I don't have to add OHs.
Well, then you may not have to. You may be okay.
Oh.
It's not absolutely required. So if you're doing the manganese one, I added 2 electrons to the MnO2 side and 1 electron to the chlorate side. And then simplify things. Wow, those H2O's canceled out on me. So did the all those H pluses. So in this question, all the H pluses were gone. So you're done. You can't convert any H pluses to OH minuses, right, in that question. So you just quit. Whether you're in acidic or basic solution, you're done. Okay.
So you guys see the charges, is that okay? Because there's a positive and negative charge, but on the other side there's no charges.
So are you talking about right up here on the top?
Positive 2 and on the final answer.
Oh, and the final answer.
Yeah.
Positive 2 and a negative 2 would give me 0. So on the other side is 0. Okay. Yeah, it has to be the same charge on both sides, whether it's 0 or 2 or 3 or negative 1. It has to be the same number on both sides. So we're about out of time, but try some of these and come by. Like, that's what the quizzes are for, give you some feedback. So if you're not sure on this stuff, come by. In about 5-10 minutes, I can work with you, and you'll be comfortable with it, right? Because these classes are tough. The general anything. They move on from one thing to the other. So come by. Like 11 to 1 every day. The lab times, great to come in and ask questions. So have a good weekend.